We would rough at 10 thousandths and we would finish at 5 thousandths. Well, we don't have 5 as an option. We could go to 6 or we could go to 3. Either one of those would be fine. I'm gonna go to 3. It's gonna give me a little nicer finish. I don't like to go to 1.5. That's really slow and it takes all day. So 3 will work good, especially since we're dealing with aluminum. Honestly, 6 would probably be just as fine. So right now we've got that set at 3 thousandths per revolution. The way this works now, when I turn the spindle on, this is engaged. If I want this to actually feed, what I need to do is just take this handle right here and pull this out. And as I pull that out, it will engage, and you can see the quill lever coming towards me, and the head is dropping. And it's dropping at a rate of 3 thousandths per revolution. So every revolution, 3 thou. Every revolution, 3 thou. Very similar to the lathe in that aspect. So I could sit and watch this cut air all day. Otherwise, I can just get it closer. So I'm just gonna do a test here and run it all the way through and make sure it's doing what I'd expect. So I'm gonna get it down to about here, and then I'm gonna engage it. Shouldn't really cut anything, maybe just a little light chip because it's rubbing just a little. It gets down to the base of it, the quill stop will hit, and right there, it pops, and now my auto feed disconnects. Then what you have to do is just manually just lift that up. So we've proven out the depths and the power feed and all that is set now. Now what we need to do is start working on our size. And we have to set our RPMs. While I'm thinking of it, let's just set our RPMs right now. So we're boring a diameter that is going to be 300 thousandths. That's a nice number just to work off of. There's a misconception sometimes in milling that you're gonna set it for the diameter of the bore bar of the RPM, but it's really not the bore bar. It's the diameter of whatever you're cutting to. So when you're milling with like a 1/2 inch end mill, sure, it's gonna mill a 1/2 inch slot and you're gonna use the math on a 1/2 inch. But here you're using a boring head, and this boring tip can be adjusted from small diameters out to very large diameters. Now, if you're on a very large diameter, you don't want that spinning ridiculously fast because you're cutting more circumference, there's more material coming off of there, and it's making contact. So if you go ridiculously fast, you're gonna have your speed off. So what you base your RPM on is actually the diameter that you're going to bore. So we're cutting aluminum, we're gonna use 200 surface footage. So we're gonna go 200 times 4, and then we're gonna divide that by the diameter of our bore. So this bore that we're doing is 300 thousandths, so I divide it by 0.3, and I come out at 2,600 RPM. So that's the RPM I'm going to set it at. And as we're working up on each one of these holes, we want to change that RPM and slow it down a little bit more and a little bit more. So I'm going to turn this on right now, and we're going for 2,600 RPM. There we are. Looks good. Going here, I think we're all set. Now we just need to go and make contact and make a cut. So we know that this hole measures approximately 250 thousandths right now. We drilled it with a 1/4 inch drill. That's 50 thousandths smaller than we need to be. So we have a little room to work up and navigate here, and that's what we need to do right now, is just take some cuts and slowly work up to our size. So let's chat about this for a second. This always gets a little interesting understanding these tolerances. So this is 300 thousandths. We need to be 300 thousandths, and according to blueprint, 3 decimal places plus or minus 1 thou. So we can measure from 299 to 301. Anywhere in between there is considered good. So we have gauge pins that come in an increment of 1 thousandth each. So you can see, 293, 294, 295, 296, 297, 1 thousandth increments. So what we're really shooting for is we want to see a 299 gauge pin drop and a 301 gauge pin stop. So rather than shooting for right in the middle of the tolerance of 300 thousandths, I will actually shoot closer to 299. Because in reality, if I use a pin that measures 299 and it does fall in the hole, it tells me that that hole is larger than 299. So if I try to make it for 300 to fit, I know I'm somewhere between 300 and 301. If I go too big, I can't add the material back on. So I'm gonna try to go small. I'd rather it come out small than too big, because I can always make small bigger. So that's kind of the mentality as we're going into this. So we're 50 thousandths shy of our size right now, or truly about 49 thousandths. So I'm looking here and I want this to cut just a little bit off. So it's very close to that wall right now. I can see where the cutting edge is at. So what I'm going to do is just adjust this a little bit, and we're going to get it to cut. So right now, I'm looking on here, and there's no relevancy whatsoever right now to where that bore bar is and where this is at. These numbers mean nothing until I take a cut, and then I actually truly know what size I'm on. And I think this will be hard to display because I don't think you're going to be able to see these numbers. But right now it's sitting between 0 and 10. So I'm basically right on the 5 thousandths right now. So I'm going to pick this up, and I know I need to move out a little bit. I'm just going to guess maybe 15 thousandths from here. So I'm going to turn this. Okay, so that was all backlash. So right now I just picked up all the backlash. So there's actually my adjustment. As I turn it clockwise, that's going to adjust it out. So, all right, now I'm at about 21. So now I'm going to turn this. I'm going to turn about 15, or I'm just going to go about 19. I'm going to take it to 40 on this dial. So right here, close. Okay, so I'm at about 40 thousandths there. That should take off, I don't know, maybe 10 or 15 thousandths out of the hole, and this is to be determined yet. I can see when I come over now that as I bring this down, it is dragging and it is going to cut something, so I know for sure it's going to oversize that hole now. So, and again, with 50 thousandths, we have a little play room here. So we will use some coolant on this operation, so we'll just get the mist coolant going here. Let it pick up for us. There we go. Just getting a little fluid. You don't need a crazy amount, just a little bit there. And it kind of sounds wispy when it goes through there. You'll hear it kind of, the air hitting this because of the interruption. Makes a little racket. So that's coming down. I'm going to bring my quill down close to it, and my coolant's on there. I'm just going to engage my power feed. There goes some cut. It disconnects, and I'm just going to lift this up manually and stop it. Move my coolant nozzle out of the way, and maybe just use a little air because I don't want any chips in here for an accurate measurement. Blow that free. And now we're going to check this hole size. So I could use a caliper. Just for reference, we'll do that just to get close. And I might have a little fun getting in here with a caliper. We can get a rough idea. So with the caliper, standing upside down here, we're about 269. So about 269. We're going for 299, so we've got about 30 thousandths to remove still. Now, that tool again, this is only accurate to, plus or minus 2 or 3 thousandths. It's not the best for something like this, so we're needing to step into a different measuring tool. So the gauge pins are great because they're a functional tool that you can test, and that's probably what you'll go to. But if you want to practice, we do have some other tools you can use as well. In here, we have these little called small hole gauges. And these look like this, and we're going to use a micrometer along with them. So we use a 0 to 1 mic and the small hole gauge, and we'll try to get an actual number here that'll be more accurate than my caliper. So to do this, you got to find the one that's going to fit between your hole. This one goes 200 to 5 millimeter. This one goes 300 to 7.5 millimeter. I don't think this is going to fit. Nope, we do have to use this one. So we're going to go 200 to 5 millimeter. The way these work is that when you pull or you screw this down, there's a V that comes through there, and it splays open that split in there, and it gets larger and larger the deeper you pull that through there.